Hello there, Year 5. This is our science class. Welcome back to my channel. And today we are going to start with a kind of short revision. Please have a look at this image behind me. You can see a plastic rod and a piece of fabric. These are insulating materials. Insulating means that they are not electrically charged, so they cannot conduct electricity really. You can see that there are positive and negative particles, but we learned something special. If we rub the two materials, something happens. Let's see what. So when rubbing starts, you can see that the little particles which are charged electrically start moving on to the other object, and this way one of them gets positive charges and the other one negative. So positively charged and negatively charged materials are here. So this is the base of static electricity. Why is electricity so important? What can electricity give us? Electricity is basically, you can see it here, energy. How can you have energy in everyday life? You know, energy is really important in your house. Can you tell me some electric appliances you use on a daily basis? For instance, if you wash your hair, you need a hair dryer to dry it. That's an electric appliance. But your body also needs energy. Of course, not electricity. But what do you need to do if you need energy? Yes, you need food. So food gives your body energy so you can move and live your life. Basically, food contains something's energy in it. Something else's energy. If we look out of the window, we can't really see it well today, but the sun's energy is in your food, basically. Okay, what other types of energy do we use? When you want to make your tea, you also need heat energy. What happens here when we use heat energy? Let's see. Look at this cooker or stove, and you can see the kettle there. Basically, the particles of the warmer matter move faster and pass heat energy towards particles of cooler ones. So fast particles, and they move really fast when they are heated, and energy flow or heat flow is produced. Okay, where else can we make energy? Look at this. This is a place where we make electricity, because rubbing two little objects wouldn't make enough electricity for us. We need big power plants or power stations. This is a heat power station. How can they make heat in these? If you want to make heat, you need to burn something. What can you burn? I would like to show you an image of this resource. This is black coal. You can burn this one, and there's heat energy produced. And with this heat, we can boil water, and the steam of that water can move and turn really big turbines in a power station. And then with the help of electromagnets, I can show you the simplified model of that. So with the help of electromagnets, we can produce electricity. Without power stations, we can't have electricity in our houses. What else can you burn in a power station? Black coal is one of them, but there's also rock oil. Here's an image. Unfortunately, in nature, if rock oil is spilled, then creatures will die. It's poisonous for them. So rock oil is also used in power stations or natural gas. Actually, these materials, natural gas and rock oil, are from tiny creatures in seas, and they are still formed even today. Black coal is not from tiny creatures in the sea, but from plant parts. if coal is not that old, you can still see pieces of tree trunks and branches and other fossil parts in this material, in this resource. So this way, basically, we use again the sun's energy in these materials as well. How can you have energy for your mobile phone or for a torch when you want to see in the dark? You need batteries for that. But batteries do not use the sun's energy, they use chemical energy. And basically, chemical energy is turned into electricity, into energy which you can use in everyday life. You can read this in your book, page 80. Please have a look at the textbook there. I will show you this part. So, page 80. In some cases, electricity can come from other sources like batteries. Batteries are examples of how we can turn chemical energy into electric energy. And take one more thing here. Please do not throw your batteries into the bin. Use a special kind of battery recycle bin for that thing, okay? Because they can collect these and they can recycle them in special factories. This way we can live a really nice and environmentally friendly lifestyle. Okay, nowadays more and more people think that burning fossil fuels like coal and oil, these are not that good. They produce too many different types of chemicals and too much pollution in the air. Big smoke is flying up, like you could see this here. So this is not really good for plants and animals and humanity. So what is the solution then to this problem? Let's think. There are so many things out there which can give us energy on a daily basis, because certain things can renew themselves every single day. The energy can be replenished on a human time scale, we can say that. So the energy restores every day, every year, and in our lives we can use these energy resources. But what are these? Look at this picture. The sun shines almost every day in Hungary. Hungary, especially the southern part, is a rather sunny place. So we could use the sun's energy if we have solar panels. Or when we think of wind, again, wind energy is replenished on a human time scale. We can have winds every single day, especially near the sea. And these gigantic turbines can produce energy for us. So what do we call these types of energy resources which can renew themselves almost on a daily basis? These are called renewable energy resources. Really logical name. What else is that? If you see this picture here, well, I hope you can see that the smoke is rather white because it is actually not pollution, it's steam. We use the heat of rocks down there in the ground, geothermal energy, and the temperature, the high temperature of stones can boil water for us, and again this steam can heat in our houses. Not too cheap technology, but you just need to build it once and then it can produce energy for you for many years. Or look at this image here. Lots of humans and animals produce things. Even plants are grown and they can have parts which we can't eat, but we could burn them. And if we burn them, they can give us energy. Because they are living things, we call them bio. Living is bio, if we use another term for that. And because we use them in huge quantities, we call them biomass. This is biomass energy, which is also a renewable energy source. What is that? Let's see. Different parts of crops and plants, or for example, animal residues, manure, still in many Asian countries they heat with cattle manure when they cook. They just dry that in the sun, but this can give you heat energy. And lots of waste materials from cities. So this is biomass energy. Again, renewable energy resource. But what are the non-renewable ones? The funny thing is that even non-renewable energy sources are renewed, but really slowly. They need thousands of years to kind of renew, or they need millions of years. We mentioned black coal, for instance, or there's rock oil or natural gas. So if we run out of these, actually this could cause a big problem for us. So no small wonder many scientists started searching for other options for humans. Plus, there's a problem with these fossil fuels and non-renewable energy resources. They produce greenhouse gases, and the result is greenhouse effect. What is that? You know, the earth became like as if it was a gigantic greenhouse, lots of glass panels around it. Of course, it's not glass, but the different gases which reflect heat back onto the surface of the earth. So this way, the average temperature of our planet is just rising and rising, increasing and increasing, and this is not good. What can happen if we continue to live like this? Forests will disappear. There are more and more deserts everywhere. So desertification is a typical problem after all this. A good solution can be more hydroelectric plants where water can give us energy. So is this a renewable or a non-renewable resource? Yes, it's a renewable resource, energy resource. So this could be much better for humanity. You can see a very nice chart in your book on page 83 on renewable energy and non-renewable energy. And I would like to ask you now to stop the video and write the names of different non-renewable and renewable energy sources on page 75 in your workbook. Yeah, and you can use this image from your book here, page 83. So do it now, please. Then continue watching the video. So if you finished writing all these, the non-renewable and renewable energy names there in your workbook, I would like you to repeat the keywords of the chapter, page 83. So please repeat them. Biomass, biomassa. Just the most important ones, okay? So not every word. Energy saving, energiatakarékos. Fossil fuel, fosszilis tüzelőanyagok. Geothermal energy, geotermikus energia. Global warming, globális felmelegedés. To tell you the truth, I would just say global climate change, because there are places where temperature rises, increases. There are places where there's just more rain. So I would just say it's a climate change, not necessarily a global warming effect. Non-renewable energy, nem megújuló. Resource, energiaforrás. Greenhouse gases, üvegházhatású gázok. Power plant, erőmű. Renewable energy, megújuló. Resource, energiaforrás. Solar panels, napkollektor. Solar energy, napenergia. Supplies, készletek. Okay, I think these were the most important words there. Now, please start working in your workbook, page 74, task 2. And page 72 and 3, task 1 and 2. I think this was a task, a homework task earlier, but if you didn't complete it, please do it now. So 72, 1 and 73, 2. If you finished all this, then you can even complete page 74, task 1. So I hope you can read the text as well in the book on page 80, 81, 82 and 83 on energy and the different types of energy resources. Then don't finish to complete your tasks. See you next time. Bye bye.